Okay, so for this next problem, again, these are the formulas that we are working with. We have a conversion, and then we also have this formula down at the bottom. So the first thing I want to do looking at my problem is I want to convert make sure that all of my temperatures are in kelvins. So I do a quick scan and I see that they are, so I don't need to convert anything. So reading through, I can start just kind of filling out what I've been given here. I know that I'm using this formula because this is the only formula that we have at this point. Okay, so the gas in the balloon occupies 2.25 liters at 298 Kelvin. So those two numbers go together. So my volume one, I'm going to say, is 2.25 liters. Temperature is 298 kelvins. So then it next says, at what temperature? So that's a big Q that we do not know what temperature 2 is. At what temperature will the balloon expand to 3.5 liters? Okay. So again, our equation that we have is V1 over T1 is equal to V2 over T2. We're solving for T2, so we want to get T2 on its own. The first thing I'm going to do is I'm going to cross multiply to get rid of my fractions. So V1 times T2 is equal to T1 times V2. Then I want to get T2 on its own, so I'm going to move V1 over. I do that by dividing. So V1 cancels, and I have T2 is equal to T1 V2 divided by V1. Now I can plug in all of my values and solve. So T2 is equal to, my V1 is 298 kelvins. My V2 is 3.50 liters. My V1 is 2.25 liters. Because I have liters in the numerator and the denominator, I cancel that out. And then I get my calculator. So 298 times 3.50 is equal to 1043. I then divide that number by 2.25, and I end up getting 463, and we want to round to the 100th, 0.56, oops, going off page, 56 kelvins. Again, if you can type this all in your calculator in one fell swoop, go for it, but I try not to rush that.